Right, in this video, I'm going to break it up in two different parts so the video won't be so long. Before we start predicting products, one thing we need to talk about are diatomic molecules. These are molecules that when you see the name or its symbol, you need to automatically know that they exist in pairs. So hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine are all diatomics. There are 7 of them, and if you look on a periodic table, it actually makes a number 7 when you label them. So we have hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. So it makes a number 7. And don't forget about hydrogen over there in the corner. Anytime you see something that says hydrogen gas, you're going to put H2. Nitrogen, oxygen, the oxygen that we breathe is O2. Fluorine gas, chlorine gas, bromine, iodine, etc. Make sure you always put a subscript of 2 next to each one of them. All right, so now let's look at how to figure out what we write on the product side. Our first one is a combination reaction. We know that we're only going to have one product. The first thing we need to do is write out the words. Then we will write the formulas, cross our charges, and balance. So we have potassium and bromine gas. If we put potassium and bromine together and we name it, we just call it potassium bromide. So this is naming, just like we did in chapter 7. So if we put K and Br together. So now we need to write the formulas. The formula for potassium is just K. Bromine gas, bromine is Br. But from our previous slide, it's a diatomic, so we have to put Br2. Draw our yield sign. And then the formula for potassium bromide, we write KBr. And then cross our charges. Potassium is a +1, bromine is a -1, so they cancel out. I'm not going to balance the reactions on this video. You can watch another video to learn how to balance. Our next example, magnesium metal and nitrogen gas. So if we put magnesium and nitrogen together, we name our metal just like it is on the periodic table. And our non-metal, we change the ending to IDE. So this becomes magnesium nitride. So let's write our formula. Magnesium is just Mg. And tells me plus sign. Nitrogen gas. Nitrogen is one of our diatomics, so it becomes N2. Draw our yield sign. Magnesium nitride, MgN. And if we cross our charges, magnesium is a +2, nitrogen is a -3, so we have Mg3N2. All right, our next type, decomposition reactions. Decomposition reactions, you will need a chart that's on the website. It looks like this. Blow it up a little bit here. It's the second page. And so each one, there are 5 different types, so they're numbered 1, 2, 3, 4, and 5. It tells you what to do with that type of reaction. So our first one is sodium hydroxide. If we go back to our chart and we look up the rules for hydroxides, so there's carbonates. Number 2, many metallic hydroxides, when heated, decompose into metallic oxide and water. So on this one, our product's going to be metallic oxide and water. Well, looking at this, sodium is our metal. So it would become sodium oxide and water. So now we need to write out their formulas. Sodium is Na. Hydroxide is OH. Sodium is a +1. Hydroxide's a -1. They cancel out. Sodium oxide, NaO. Sodium's a +1. Oxygen's a -2. We cross our charges. We get Na2O. And then we add to it water. All right, the next example, calcium chlorate. Well, let's go back to our chart and look for chlorates. Number 3, metallic chlorates, when heated, decompose into metallic chlorides and oxygen. Metallic chloride. So our metal here is calcium. So we would have calcium chloride and oxygen. All right, so let's write our formulas down. Calcium chlorate, CaClO3. Ca is a +2, chlorate's a -1. Yield sign, calcium chloride, CaCl. Calcium's a +2, chlorine's a -1, so we cross them. And oxygen. Oxygen is a diatomic, so I have to put O2. All right, our next one is an acid. So looking back at our chart, some acids, when heated, decompose into non-metallic oxides and water. So we need to make a non-metallic oxide and water. So hydrochloric acid, this one kind of helps if we write the formula out first. A non-metallic oxide. Chlorine is our non-metal, so it's going to make chlorine. And since this is a covalent compound, we have to use prefixes. So it would be monoxide. And water. So we have HCl produces chlorine monoxide. We don't have to cross charges since it's covalent. And water. All right, here's another acid. So nitric acid. Nitric acid is HNO3. So again, we need a non-metal oxide. So our non-metal is going to be nitrogen. Again, this is a covalent compound because it's two nonmetals. So nitrogen monoxide and water. So if we write out our formula, we got HNO3 yields nitrogen monoxide H2O. And let me check. We have 3 oxygens, so this should be, I lied to you, this should be nitrogen dioxide. And I know that it's nitrogen dioxide because one of my oxygens will go to water. That leaves 2 left. So that's why I have dioxide. The next one, potassium carbonate. So if we look at our rules for carbonates, we have to scroll back up to rule number 1. Metallic carbonates, when heated, form metallic oxides and carbon dioxide. So metallic oxides. So potassium is our metal. So we're going to put potassium oxide. This is an ionic compound, so we don't need any prefixes. And carbon dioxide. I'm out of room, so I'm going to write it on top. All right, so if we write our formula, potassium is K, carbonate is CO3. It has a -2 charge, so we need a 2 here. Put our yield sign. potassium oxide. Potassium's K, oxygen's O. We have a +1 and a -2, so we have K2O. And then carbon dioxide is covalent, so we just have to write it the way it is written out. We do not have to cross any charges. All right, so that is our metal oxide and carbon dioxide. And then the last one, aluminum oxide. We scroll down to number 5. Some oxides, when heated, decompose. So if you look at the examples, they just split apart. So this is just going to separate into aluminum and oxygen. We write out a formula. Aluminum oxide. Aluminum has a +3 charge. Oxygen has a -2 charge, so if we cross them, Al2O3. Put our yield sign. The symbol for aluminum is just Al. It is not a diatomic, but oxygen is. So now that is aluminum and oxygen gas. All right, I'll go over the other types in the next video.